Okay, so now we're going to start talking about the highly proficient side of equations quiz B. So for this one, it says that you have a line that goes through points 16 and 34, and then 4 and 16, and then you have another one that goes through 1435 and 1642. So when I work on those, I know, again, that the x value is first and the y is second. So all of these tell me the coordinate points for each of these, and the x is first. So on my first table, I know that when x is 16, that y is going to be 34. And I know that when x is 4, y is going to be 16. So if I want to write down a rule for this one, the first thing I need to find m, and I need to find b. Those are my two things. The rest of it is just y equals blank x plus b. So the way to find m, again, is if we remember that m is the rise over the run, then we can remember that the rise is the increase in y, and the run is the increase in x. So what is the increase in y and the increase in x? Well, when I look at this, I can see, let's pick a different color here. I can see that when x goes from 16 to 4, it is decreasing by 12. And when y goes from 34 to 16, it is decreasing by 18. So that means that my rise is, if my rise is negative 18, that my run will be negative 12. Let's see, I'm going to erase this b for a second here. So I can simplify that. There's lots of, I can reduce this down, and if you reduce this down, you can reduce it all the way down to, if you were to do negative 18 divided by negative 12, you would come up with positive 1.5 or 1.5 or something like that. Either one works. But now I know that my rise is 1.5. Maybe I should show the proportionate fraction. So this is going to turn into a 3 over 2. And that is 1.5. And that's 1.5. Any one of those will work. I'm going to put in, actually, I'm going to put in 3 halves here. Because I like to think about it in terms of rise over run. It makes it easier for me to graph. So now I have to go, I know that every time that y goes up 3, x is going up 2. That's what this rise over run tells me. So I can use that information here to go back to where x is 0. So I know that if we go back, I know that if we go back 2 more, that this is going to go down 3 more. So when x is 2, y is going to be 13, and if I go back 2 more, when x is 0, y is going to be 10, and we know that the value for b is the value the value of y when x is 0. So in this case, b is equal to 10, because when x is 0, y is 10. So there's my first rule. For my second rule, I do, let's see, I have 14 and 35 and 16 and 42. And so I can see here that when x is increasing by 2, y is increasing by 7. So my m is going to be the rise, which is the increase in y. So m will be 7, and x is the 7 over 2, because the increase in x is 2. So once I have that, I have part of my rule, so I can already fill in y equals 7 over 2x. You could also write this as 3.5. But it means whenever x goes over 2, y goes up 7, or whenever x goes up 1, y goes up 3.5. And then for b, I'm just going to use this and just sort of do my count. I know that if x goes up to, y will go up 7. So if x goes down to, like, let's say if it goes from 14 down to 12, that's going down to 35 is going to go down 7, which is 28. And then if we go down 2 more, that will go to 10, and 28 will go to 21. And then we'll go, if we go down 2 more, this will become 8, and this will go minus 7 and will become 14, and then 6 will be, and then 6, and then 4, and then 2, and then eventually 0. And then on the other side, I have to subtract 7 each time, so 14 minus 7 is 7, and then 7 minus 7 is 0, and 0 minus 7 is negative 7, and negative 7 minus 7 is negative 14. So now I know that my b level here is negative 14. So now that I have my my rule and I have both my rules, I can use that information to help me finish filling out my graph and my equal values method, and use my table again to find show how we would find the point of intersection in all of them. But I like to use the equal values method first. I think it's the best way to show where the point of intersection is. So I'm going to take my rules, my first rule, which was y equals 3/2 x plus 10. And the other one was 7/2 x plus negative 14. That also is equal to y. And I am going to set these equal to each other. So just this part right here is going to be, I'm just going to place those. I'm just going to say, well, if I want to find out the value for x when these y's are equal. And when these y's are equal, I know that the things that equal the y's also have to be equal. So now I'm going to solve this. Let's see. If I subtract 3/2 of x from both sides, then all of a sudden this becomes, I have 10 left over here. Actually, I'll do that in a second too. Let's see, I have 0 x's left on the left side. And over on the right side, 7/2 minus 3/2 means 4/2. So this is 4 over 2x, which we also should know is 2, because it's 4 divided by 2. And then I'm going to add 14 to this side and add 14 to this side. And then I will have 24 here, and so 24 and 0 left on the other side. So 24 equals 4 over 2. And like we said, we already know that 4 over 2 is, so this is going to be 2x equals 24. And to get rid of my 2, I use the inverse operation. I divide by 2, and I get x equals 12. So now I know that they are going to intersect when x is 12. And so maybe do I already have part of my, in my table, I already have part of my point of intersection there. So this is already telling me, I bet you that I'm going to come up with 28 when I put these in. So we are going to then do we're going to take our original rules, 3/2 x plus 10, and we're just going to take our x value, and we're just going to put it right in there. So this is going to turn into y is equal to 3/2 of 12 plus 10. So in order to figure out what 3/2 of 12 is, I could do 3 times 12, which is 36, divided by 2, which is 18, plus 10, and y equals 18 plus 10, so y has to equal 28. And then on the other side, that, by the way, matches my table up here, 12 and 28. Let's see if it's true on the other side. So 7, I'll use the same color I used last time here. 7 halves of x plus negative 14 equals y, and I am going to put in, I'm going to put the 12 right there, so it will turn into 7 halves of 12 plus negative 14 equals y. And this time I'm going to do it a little different. I know that when I multiply by fractions, I divide by the bottom and multiply by the top. So I'm going to do 12 divided by 2, which is 6 times 7, and that makes 42 plus negative 14. And that is going to make 42 plus negative 14 also equals 28. So yay, now I know that my table is going to show my table of contents at 12 and 28, and my final answer is going to be 12 and 28. But it's not good enough to just find the final answer. We're supposed to show how we found it in all of the places. So I'm going to try to go through this until I can get to 12, and I know that when I go down 2 here, I go down 3 on the other one. So what I'm going to do is I am going to go, let's find a good color here. So if I start at 16, I already know that 16 and 34 are a point on the line. So if I go down 2, I will get to 14. And if I go down 2 more, I will get to 12. And then let's see if that happens on the other side. I should be, when I go down 2, when x goes down 2, y goes down 3. So this would be minus 3, which is 31. And then this would be minus 3, which is 28. And so when on my table on both lines, I can see that 12 and 28 is on both of them. So that's how I would show my point of intersection on my table. I have both of those points on the table. Here's how I show it on with my equal values method. And then finally for my graph,